Hello to Darkness344 here. Today I'm going to be showing you off this super compact worm memory, or WORM, which is write once even, read many. So this is very useful if you are space limited, and as you can see, this is pretty much the same profile as in width as just standard ROM. And it also means you can write to it as well, so you don't have to go into your computer and place all the torches manually. And it is a very cool concept, and I will be showing you how to build one of these today. Just take a note that this is the more compact version, which means it's a bit slower in writing. However, since you only write to it once, it really doesn't matter. I made several of these versions. The other version was just 1 block wider, but you really want it just 2 blocks wide each cell, because that just makes it a lot more efficient. And it also means you can convert standard computers like my standard computer's all the way over there, so I won't bother showing it off. But it basically means you can convert standard computers with just normal ROM to this, and it also means, well, this is just basically a lot better than ROM, just for the reason that, well, you don't have to go in and program it. You can just program it up here. You select what data you want to be inputting, you select what cell, and it will write to the cell. And the reason why you'd use this is because if you have external compilers, or just one, like a compiler program that you want to copy to your computer, but you don't want to have to make your computer use RAM so you can do it multiple times, then you'd use this, because this is a lot more space efficient than any RAM device. I'm just going to extend this out real quick like this, and the only reason why it's going down is because if I had this on the same level as this, it would interfere. But basically, as we can see, we have our standard, just our normal lines with our redstone torches, so basically like a ROM on your normal computer. However, we have these pistons with these glass blocks on top. I'm not using solid blocks. You could use slabs or something like that instead. Not using solid blocks because this redstone would create a torch burnout clock, and you don't want that. So transparent blocks mean the torch cannot send a signal to the redstone. And basically what we tell it to do is whenever we want to write, we tell it, instead of writing ones to it like standard conventional RAM, we actually write zeros to it, because you fill it in with redstone torches already, and whenever you want to write it, you break all the zeros. So say I wanted to write the number 1001, instead of writing 1001 to it, I would write 011, so it would pop off these two torches, and you have 1001. When you select the read output, which I'm going to have to break these, and as you can see, it basically does that. And yeah, because so basically what that means, you can just invert your input as I've done here, and it just makes life a lot easier. So what I was saying about this being slow is because each additional line you add, it adds 1 tick of delay because of these repeaters. However, I did have a design where it doesn't add 1 tick of delay per each cell, but it means the cell is wider in this regard. So instead of being like 2 blocks apart, it would be, as I've already said, 3 blocks apart like this, and that would be very annoying and not compact at all. And this, I just wanted to make one as compact as possible, because you only write to it once, so it doesn't have to be fast. And of course, technically it's only write once, but since it's Minecraft, you can go in and place the torches back if you want to reset it, so it makes a nice thing. So say if your program was already burnt into it, but you just really didn't want it, instead of having to break it all and rebuild it, you could just go in and place the torches back where they are, because RAM means you don't ever have to do any of this placing back in. However, RAM is a lot bigger. I'm not sure if I have an example over here, don't I? This is 2 cells of RAM, and as you can see, it's let's count, 1, 2, 3, 4, 5, 6, 7 blocks wide, and this is the smallest cell you can pretty much make in Bedrock Edition anyway. There's a chance you can make a smaller cell, but I mean, if you can, go for it. I'd like to see some suggestions, but this is a very small cell, and it's kind of slow on the reading as well. Like, it takes a bit of time. As you can see, that was 1, 2, I think it's 1, 2, 3 ticks for the read, which I mean is not too slow, seeing as every single cell is 3 ticks for the read, but it's still slow enough that ROM is only 1 tick for the read, because whenever you read it, it just reads like that, and the redstone torch instantly is only 1 tick of delay. As you can see, there's only 1 tick of delay, so that is why you'd use ROM. However, this is only 1 tick of delay too, because all you're doing to it is modifying your existing ROM memory, and basically putting a little writer above it. So all this device does above the ROM is write to the ROM. So instead of you writing manually to the ROM, you have this device that writes to the ROM, which is pretty clever. So, oh yes, I will show this off in a later video. I'm still working on it. I will come to that maybe later in this video as well. I have some other cool concepts to show off as well. I have a lot of videos. That is what I've been working on, by the way. First of all, let's actually show this off. So over here I have 6 different cells that I've built. I should have built 7 really, but 6 is fine. And we can basically input data. So say I wanted to put in the number 1111 to this cell over here. I could just hit write, and I input it in, and it didn't break any torches because it didn't need to. That was a kind of bad example then. And when I read from this cell, it will read 1111. Note that cells that haven't been programmed yet will always read back 1111, because they haven't been, like, the ones haven't been broken off. So there may be a simple way to fix this by inverting it again and then inverting it again, but there's really no point. Why would you do that, you know? So say I wanted to write 1001, and we're going to write it to the same cell again, actually, because we didn't break any torches that time. We're just going to write it, and as you can see, it broke those redstone torches that were representing the zeros. And so when we read it back, we get 1001, and it will be like this forever. But as you can see, you cannot write this cell again, just because the data is already corrupted and you can't write to it again. So now let's try a different thing. So we're going to do 1100, and we're going to write it to this cell instead. And as you can see, when we write to it, it writes 1100, and as you can see, there we go, and just like that, pretty simple. And it's a nice and compact, all my own design, and I guess I can do a tutorial on it. So first of all, also in the future I will actually be showing you a full tutorial of this with my 4-bit computer, with also a few more modifications that you can do with my 4-bit computer to make it pretty cool, because I have an upcoming project which external compiler, may I add. So I'm just going to show this off real quick. It will not be long, but basically, yes, I am with my dad. We are writing a program to be an external compiler, and you may not know what this is, but basically this is just a shift register, but basically the program will, like, write in stuff. Oh, I broke it by hitting the tripwire. As you can see, you can write to the shift register, and then whatever the contents in the shift register is, it will be written to your program memory. And I'll show you, and by writing to the shift register, I'm going to be using a piece of external software that I'm working on with my dad, and it will basically mean you can input some machine code to it, hit run, and it will write all that machine code to your computer. And then I have another piece of software that I've been working on Scratch. You know, I know Scratch, it seems a bit of a step back, and it is quite a simple programming language. However, there are a lot of things you can do with Scratch, and this is one of them, where I've been making a parser. So basically you write some code, which will be like my own special code that I design, and then you click parse and it turns the code into machine code. So pretty cool project. But yeah, so let's start the tutorial on this, and I'm only going to be doing this version. I'm not going to be doing the free wide version, just because I'm pretty sure you guys would rather have this. Leave some comments if you want the free wide version, I guess, but there's really not much point of it. It just means it's faster write times. Instead of having to have the repeaters here, it just means it's a bit faster. But yeah, so first of all, you're going to want to have some actual, you're going to want some ROM memory first. So you're going to want to have a few lines down like this. I'm going to do, we'll just do 4 cells again. And these are basically your read lines. So this is going to be what the data is being read to. And let's get some lamps as well. My inventory is a bit of a mess. But as you can see, this is the output of your thing. I've forgotten what was there. So now we're going to actually want to build some ROM. So the way to do that, this is the simplest ROM design out there, I'm pretty sure. You just bring some lines like this, and we're going to do 4 again, just to show that it's easily scalable. I'm going to break these because we do not need them. Run some wire across these lines again, and then invert them like this, and I'll show you why. And we're going to put levers here so we can toggle them. And then basically what you want to do, whenever you want to write some data to one of these ROM, you just put some torches down, and whenever you want to read that data, you power this torch, and as you can see, it reads back our data, which means you can do some cool stuff like this. So if our first cell has 0101 contained, we can read that back whenever. This one has 1010 contained, we can read that back whenever. This one has 111 contained, and we can read that back wherever. So we don't actually need these torches here yet, because they do get broken sometimes in the building process, so don't bother placing them in. But first of all, what we're going to want to do is make a space for our pistons. I'm just going to actually extend these lamps out a bit further so we get a bit more room to work with, and there we go. So if our torches go here and the glass block to break them, make sure it's glass or slab. Slabs also work, because if it's a normal block, as you can see, it don't like it. So if it's a glass block, it doesn't do anything, because the redstone torch signal cannot get powered. Basically what happens, this redstone torch powers this block, and this block powers this dot of redstone here, and this dot of redstone powers this torch, creating a torch burnout clock, breaking the system. And you don't want that, you want a glass block here, or a slab, or C3 block, as I said. So we're going to place our pistons down like this. You can use regular pistons, but it means when this glass block gets pushed down, it will not be retracted, so it just makes life easier using sticky pistons. So instead of having to go through breaking the glass, placing it again, and placing the torch, all you have to do, is because it'll retract it automatically, is just place the torches again. So as you can see, we have a piston, and we're just going to go like this to make it easier. And everyone where there's a redstone line, we're going to place a thing and break all the remaining ones, just like this. And on top of these, we're just going to place some blocks like this, and some redstone on top of them like that. Then, I'm pretty sure we go up like this, and we're just going to make a line, it just makes it easier building like this. And then you just place torches in like this, and you break these blocks again. It's just a very easy way of building, is instead of having to go up like this, place a block, break these, you just build a line of blocks and then break all the ones in the middle. And we're going to place redstone on top of these too. So this circuit we're creating is called, I think it's a multiplexer, I'm not too sure, but basically I'll create a simple one here actually. We have a torch here, I mean 2 inputs, this one has a repeater, this one has a repeater too, and some redstone up like this, and this is our output. And then we have a sticky piston like this with a block, and this is our control line. So you can either do, by default input 1 is what goes out and input 2 does not, but when we turn our control line in, input 1 does no longer go out and input 2 now goes out. So that's basically the circuit we're creating. We're actually modifying this a bit, so it's just a bit different. So instead of having 2 inputs, we only need 1 input and a control line. So we can do that. We're going to use a pistonless design because it just makes it a bit easier. So we have our input like this, we go into an inverter, piece of redstone, and another inverter, and this is our output. And the way we control this is we have a control line going into this as well. Seeing as it's inverted, the control line does not do anything to the output. And as you can see, we can run line through, but if our control line is on at the same time our input's on, our inputs will not be output to the control line. So pretty cool circuit, and that's what we're basically making here. We're just making a slightly modified version of it to fit in this small area. So the way we do that is we're going to place a piston like this and a few more till we get up to here, and we're just going to do that on all of these. Side note, you do not need this middle one, and I'll show you why. It's because we're placing redstone blocks on top of these, and basically when these pistons extend, this one and this one gets powered. It's not just this one extends and this one gets powered. So if you could do this and all of these would get powered, you don't need to do this too. So technically you could remove this one, but maybe for scalability you'd want to include it just so it makes it easier to scale. I'm just going to leave it in for now. This design I did not include it. As you can see, there's nothing down here. You can leave it in, you can take it out. If you leave it in, you get it looks like this, but if you take it out, you just place a redstone dust down instead, and it means you can fly through and place the repeaters down easier. So I guess we're just going to leave it out. So now that we've got this, we're actually going to have to find a way to power these pistons, and there are several ways. Oh, we could go out like this. Oh, but that goes into our next cell, so we do not want to do this. We could go out like this, but it interferes with these wires. So the only way to power it is either have a torch like this, but there's stuff on the bottom, so we couldn't do that, or just place a block like this, and we need to power this block somehow, and we can do that by doing this, by putting an input into it like this. As you can see, it powers the piston. However, if we use redstone here, it connects with this line, and we cannot place a block here either, as this redstone powers this block powering the piston. So we just have to use repeaters here instead. On this one, seeing as there would be a block then a piston, we can just break these, leave it out, and place a piece of redstone down instead. And we'll just have repeaters on every single one like this. So it goes repeater, block with the piston, repeater, block with the piston, repeater, block with the piston. But since we're missing this one out, we can always just leave it as redstone, as I've said already. So now we're going to have to move this again. So we're just going to move this down like this. So we still have our control line. And then we can have a new control line for this one as well. As you can see, we can do it. There is a bit of delay between them, but it doesn't really matter too much. It doesn't really affect circuits too much. So we're just going to pull this down so it's easier. And then we need to send data in somehow to these lines over here. And the easiest way to do that is just to create another bus, but with the torches on the side like this. And then what you can do is place a block on that torch and just continue till you've done all of these. And you can just extend these out like this. I'm just going to extend them the whole cell's way. And of course the inputs have to be inverted. And then we just run redstone down like this to each of these. I'm going to build up another one real quick next to this. And we will give them a test out once I get the other one up, just because you'd want another one just to show you that it's scalable. So pretty simple to make. We can use this one to help guide us. And they won't interfere with each other from my testing so far. Hopefully, anyway. So there we go. And then this one's nearly finished too. Someone is setting off fireworks apparently. And on each of these, of course, you want your torches as well. So remember to include the torches, or else you won't be able to, your data bus will not be able to power them. And that would be quite unfortunate. So of course we have our repeaters. Make sure the repeaters are facing the direction your control line is coming from, or it will not work. And there we go. That is another cell done. And we're just going to turn these off because they do not need to be on. So there we go. Now, the way we actually write data to this is, I'll show you in a minute, but first of all, we have to place our torches back in. And these, you could call them fuses. And this was an idea by my friend, Duxon1124. And he was saying how, like certain memory devices, like write once memory devices, have fuses in, and the way it writes to the fuses, the way it writes to it is by breaking those fuses or blowing the fuses. And that is technically what this does, as it smashes the redstone torch, blowing the fuse technically. So here we have two cells now, and we have our inputs over here. And I'll just make sure, yeah, I did put in all the redstone torches. So now we're going to write to it. So let's write the number 1001, and the way we do that is flip these. Remember, this line is inverted because we're actually writing zeros to it. We're not writing ones to it, we're writing zeros to it, because by default there are ones on it, and when you write zeros it destroys the ones. So that's what we're doing in this regard. So 0 1 1 1, no, 0 1 1 0, but we're actually writing 1 0 0 1 over here. And now let's just write it to our first cell like this, and when we flip it, it should hit out these torches, leaving us 1 0 0 1. And we're just going to extend it up again. So when we read it, that's what we had. And now let's just do the opposite of this. So instead of 1 0 0 1, we're just going to do 0 1 1 0. This would probably be easier if I had redstone lamps down here to visualize. So 0 1 1 0. And we're going to write that to our second cell. We cannot write it to our first cell anymore, because remember, the data's already been written and it is only write once memory. And as you can see, we write it to this cell, and I'm pretty sure I forgot something. Yes, I did. I forgot these torches. So let's just put them back. And as you can see, it has written that. So now, when we read it, it will come out as 0 1 1 0. Perfect. And we can choose which one we read at a time. Nice and simple like that. And you can have your program counter hooked up to this, and then a multiplexer or all your control lines hooked up to this, and write data to your computer. And I will be showing you how to hook the 4-bit computer that I did a tutorial on up to this for a full external compiler. And I'll also be providing software to actually program it, and like to actual code it when it comes out. And I'll be using some very cool techniques with this shift register. I'm pretty sure the reason you don't see this type of shift register on Java edition is because repeaters are a bit buggy on Java, but yeah, this is a really good shift register. I really don't know why there are really complicated tutorials on it. You have to use like proper NOR latches and stuff. It's really weird, but this is quite simple. You can either write a 0 to it, or you can write a 1 to it. I'm just going to write 2 1s, as you can see, and I'm going to write a 0. And you can also reset it. I don't see why people don't use this. Maybe because you can only write one way, you can't write the other way. Who knows? But yeah, I hope you like this, and hopefully you'll enjoy my upcoming video on the cube. I might also do an ALU tutorial, because I've designed a new, much more simple ALU. And this cube will be pretty cool to show off. And I got this inspiration from Nubosaurus's 40 by 40 by 40 challenge. However, this is with a slight twist. It's 30 by 30 by 30 and boosts the same or similar specs, kind of, yeah, ish similar specs. But yeah, thanks for watching. I hope you like this. Please like and subscribe, and I am out.